Lauren and I are here to talk about how we're using a tool called Corpora to improve and wrangle ARC's large data set of bibliographic metadata so it can be ingested into the Links triple store. Corpora is ultimately a web application Coder has created over the course of the past 5 years in order to serve the needs of a variety of DH projects. And part of our work with Links will include writing up robust documentation for the tool, and open sourcing Corpora to make it more widely available. So we're excited to share it with you today as a kind of preview of coming attractions. Before we say any more about Corpora, however, I need to speak for a minute about ARC. ARC is chiefly an aggregator of metadata for scholarly digital artifacts. And if you're interested in learning more about ARC, check out the link at the bottom left. In terms of organizational hierarchy, there is a central ARC office here at Texas A&M, but the reason we refer to ARC as a consortium is that the metadata is ultimately gathered and peer-reviewed by period-specific communities of scholars. Each of these communities, or nodes as we call them, has their own web portal which allows their users to search relevant subsets of the ARC catalog. For instance, the nines.org portal allows users to search for artifacts pertaining to the 19th century, 18th Connect to artifacts from the 18th century, etc. These portals, in other words, represent particular fields in the humanities. There are currently 5 active communities with 2 additional in the pipeline. So far, ARC has aggregated metadata for roughly 2 million digital artifacts and counting. At the ARC office, we receive this metadata curated by a project manager for one of these 5 nodes in the form of RDF XML files encoded according to an official ARC schema. This metadata contains information like title, author, genre, type of artifact, scholarly discipline of interest, etc. So if you're interested in that schema, feel free to check out the link on the bottom right. As I mentioned, ARC's role in the Links project is as a data contributor. Our broad goals are first to automatically ascribe an authoritative URI to each of the nearly 600,000 named entities in our catalog and human vet them when possible. And my colleague Lauren will speak to that part of the project later in the presentation. The second goal is to then convert the roughly 2 million records we have into linked open data triples that adhere to the Links ontology and can therefore be ingested by the triple store. To give you an idea about ARC's current data infrastructure, all of ARC's metadata ultimately lives in XML files. Those files are stored in a Git repository associated with the archive they belong to. So, for instance, ARC aggregates metadata for all the digital artifacts of the Walters Museum. The XML files containing that metadata live in the Walters Git repository. And there are over 300 different archives or Git repositories like that comprising the ARC catalog. When we're ready to ingest metadata from an archive into our catalog, we pull down that archive's Git repo, feed those files into the ARC indexer, which parses the XML, and finally stores the metadata in a Solr index that allows us to search, sort, and facet according to the various fields comprising our schema. While the current ARC infrastructure makes it easy to take all the metadata belonging to an archive and index it, it becomes frustratingly difficult to make a small change to a single record. To do this, we have to find the repository belonging to that archive, clone it, search through all the XML files as part of that repo to locate the one containing our record, then modify the XML, commit that change, and then fire off the indexing task again. Similarly, should we make a large structural change to our taxonomy of genres, types, and disciplines, changing those values in our metadata is a massive undertaking, as we have to clone every repo, write a script to check every field for old values, change them to new values, commit to their respective repo, push, and reindex. This amounts to changing over 100 gigabytes of XML data. We also have to go into the source code of our ARC indexer, which was originally written in Java, and ingest the logic that tries to restrict values according to our taxonomy. Our last attempt to make such structural changes was about 5 years ago, And it was such a hassle that we began planning a migration away from what we now refer to as our legacy ARC infrastructure. We've also found that while our Solr index is fantastic at full text searching and faceting, it becomes impossible to do other kinds of querying and analyzing. We once attempted, for instance, to index the entirety of the English short title catalog with the goal of tracking not only the published books, but also their holdings across all the libraries in the world. And while our metadata schema could, in theory, describe this situation, our Solr index fell on its face when trying to query for these records in that hierarchical fashion. A single query ate something like 17 gigabytes of RAM and then finally timed out. Finally, our legacy infrastructure was mostly coded in Java and Ruby. And while there's nothing wrong with those languages, it means that we have to either have staff members that are experts in those languages, which we don't, or that we have to contract out anytime we make a significant code change. For these reasons, we decided to migrate ARC to Corpora, but it was going to entail such a massive amount of work that we kept putting it off. We finally found the impetus we needed, thanks to the Links project, and so we are close to kind of being done with that migration. As I mentioned, Corpora is designed to serve the needs of a variety of DH projects. And in my experience, no two DH projects are alike in terms of what content types need to be captured, analyzed, and displayed. Another way to put this is that each project is a little self-referential world unto itself with its own uniquely inflected ontology. So for instance, ARC needs to keep track of federations, types, entities, roles, agents, disciplines, etc. And each of those things need to be able to reference each other in specific ways. One of the reasons we refer to Corpora as a dataset studio is that it has a built-in content type manager that allows you to create arbitrary content types to build out your schema according to the unique needs of your project. A content type in Corpora is ultimately a set of fields that together form a schema for the object in question. The schema for an entity in ARC, for instance, is composed of a name, a type of entity, an authoritative URI, whether or not it's been verified by a human, whether or not it needs attention, whether there are alternate names for this person, etc. When creating a field for a content type, you can select from various data types, which you can see listed there to the left. And many data types provide other configuration options, such as the text, large text, and HTML types, which allow you to choose a period-specific list of synonyms the search engine should use when querying the data stored in that field. As another example, the cross-reference data type allows you to designate a field as a reference to another piece of content stored in Corpora. For every field, you can also choose whether the field should be indexed by the search engine, should have a unique value, should be multi-valued field, etc. Once you've built out your schema, it can be exported as a simple JSON file for use in other projects by clicking the export button in Corpora's content type manager. Schemas can also be imported using the same format. Once a content type has been defined, users are able to create or edit a piece of content using a simple web form that gets automatically generated, where the input controls correspond with the data type for each field. With large-scale projects like ARC, of course, there are other ways of loading content, which I'll speak about a bit later. Once data has been loaded into a project, and here I'll switch to the live instance of Corpora. Corpora allows you to browse and search through your content by content type. Here, for instance, I'm searching all of the artifacts in ARC for the author Susan Brown. This interface allows users to search across various fields. Once you've selected a field, you can choose different types of search, including, exact search, the text search, which by default is a kind of fuzzy search. You can do wildcard searches, and even search for a range of values. And of course, you can sort your results, etc. So upon clicking on any one of these results, you're taken to that piece of content's unique URI, which by default shows you an HTML representation of the data. In order to fully support the kinds of analyses and visualizations that scholars in the humanities need to produce, however, simply browsing data in a tabular format is not enough. So in Corpora, you can click on the Explore tab and see a network visualization of how that content is interconnected with other pieces of content in Corpora. Here is the artifact in question. And I can see kind of at a glance that it belongs to the victbib archive and is federated with nines.org. And if I'm curious about anything, I can click on a particular node, I can sprawl it out and sort of chase a line of fascination about my data in that way. You can also explore the interconnections between disparate pieces of data that you select by searching. So here I'm searching through all of our entities, again for the author Susan Brown, and I see that there are quite a few authors that appear to have roughly the same name. So if I wanted to, I can select multiple kind of items in Corpora, and with the selected items, I can choose to explore them, which again opens up a kind of network visualization. And this, for instance, might be useful to determine whether these are actually the same author, or whether they should be merged, which is something that Lauren will be talking about later. By and large, DH projects are about examining existing cultural artifacts. And while it would be nice to live in a world where the data for every project comes in a nice, neat set of Excel spreadsheets, the reality is that scholars come to us with a wide variety of digital data in disparate formats, whether it be a set of PDFs they want to OCR and annotate, a hard drive full of images they want to create metadata for, a database full of bibliographic metadata stored as MARC records, or as in the case with ARC, a collection of over 300 Git repositories containing XML files. While Corpora allows users to upload those source files into their corpus, there's simply no one-size-fits-all approach to then extract that data and save the results as instances of Corpora content types. For this reason, most large-scale projects like ARC require that data be ingested programmatically. In order to make the development of that code more convenient for developers like myself, Corpora comes with a built-in coding environment in the form of an IPython notebook that allows you to create and test your code one step at a time using the Python programming language, which has become a kind of lingua franca for academic coding, particularly in the sciences, but increasingly in the humanities as well. Once code has been developed inside that Python environment, it can be easily converted into a task that any authorized user can then run on your corpus. This screenshot, for instance, shows the form you fill out in order to run the task called index arc archive. When launched, and by the way, all the tasks in Corpora are launched asynchronously. They're kind of tracked by a separate component, so you don't have any web timeouts or anything like that. When launched, this particular task pulls down the latest commit for the archive in question, parses each of those XML files in order to create or update corresponding pieces of content belonging to the ARC corpus. Aside from allowing you to define your project schema and load the data in according to that schema, Corpora provides several means for you to then present that data to the public. The first of which is a simple out-of-the-box API that spits out a JSON representation of your content. And getting to that representation is as easy as just kind of putting the word API in the kind of URL for the piece of content in question. Aside from simply allowing you to get to your data as JSON, Corpora's out-of-the-box API allows you to search, sort, aggregate, and explore the connections between your data. By manipulating the parameters of your API requests, you can perform, fuzzy searches, exact, wildcard, or query data belonging to a range of values. You can also simply provide the URI for a single piece of content and see the other content that either references or is referenced by that content. Indeed, the web front end for Corpora ultimately relies on JavaScript calls to these API endpoints in order to present the data. Ultimately, what makes Corpora's API so flexible in terms of how you can query your data is that every piece of content in Corpora lives in 3 types of databases at once. While technically any one of these databases, or even a relational database like MySQL, could provide much of this functionality on its own, by leaning on MongoDB for quick document retrieval, Elasticsearch for searching, sorting, and aggregating, and Neo4j for exploring the interconnectedness of data, Corpora is able to effortlessly scale in terms of the size of your data set without sacrificing performance. In truth, the secret sauce of Corpora is precisely this ability to take the schema you create for your data and automatically handle the complexity of creating corresponding schemas across these 3 databases. Another ingredient to the secret sauce of Corpora is the fact that it's built using the Django web framework. This allows the code base for Corpora to be inherently extensible. All of the special tasks like indexing and archive live inside of a plugin folder that can be easily added to a given deployment without directly modifying the Corpora code base. And speaking of the extensibility of Django, one of the more popular features of Django is the ability to leverage Jinja 2 templating when outputting data. What you see here is the content type template editor, which allows you to create any number of templates for representing your content. So in terms of presenting data to the public, you can create templates for rendering custom HTML, XML, JSON, or in this case, turtle statements that generate on-the-fly representations of your content depending on your presentation needs. Here, for instance, are snippets of the same piece of content being represented in both the RDF XML format used by Arc and the turtle format appropriate for ingestion into the Links triple store. Each of these representations can be accessed by visiting the content's unique URI and just kind of appending the name of the template you wish to see to the end of the URL. So here's that Arc RDF XML, and here is the same content represented as turtle statements. We're still kind of working on the, I've still got some white space issues and some other things to deal with here. But a big shout out here to Aaron Canning, the Links ontologist, who did all the heavy lifting to create the turtle representation for Arc's metadata. As a final note before handing things over to Lauren, I wanted to mention that while we're fortunate enough here at Coder to have a rack of servers at our disposal to host Corpora at scale, Corpora's entire stack, including the 3 databases, the web app, and the Nginx web server that orchestrates all those pieces, all of that lives inside of Docker containers. As such, I do the majority of my development and testing with Corpora running on my laptop. Which means that regardless of the kinds of computing resources a researcher has at their disposal, whether it be a Windows desktop or a MacBook Air, Corpora can run on it, allowing them to build, improve, and wrangle their data sets without needing a sophisticated server infrastructure.
My name is Lauren Lipa, and I am the project manager for Arc. My job primarily involves indexing the data for new projects and assigning and verifying URIs for data already in our catalog. Both of these tasks are necessary for our collaboration with Links. The indexing of new data allows us to access the full metadata for each project within Arc, and the addition of URIs allows us to work towards these projects being interoperable through linked open data. As Brian noted earlier, the amount of data managed by ARC through Corpora is immense. Within our 5 active research nodes, not including the 2 that are still forthcoming, we include the data for more than 300 projects, which makes for more than 2 million points of data. And this number is constantly growing. Within the last 2 weeks, for example, we've added nearly 1,500 new RDF files from the Thomas Gray archive. And this week we'll be adding another project, the Du Bois Papers Collection, which includes another 1,000 entries. Here, you can see a very simplified version of ARC's data structure, at least the part that is relevant to my discussion. All of the data within ARC can be linked to one or more artifacts. An artifact is the individual item being cataloged, whether that be a book, a letter, an engraving, a piece of music, etc. Each of these artifacts is connected to a wealth of metadata, including a unique URI assigned by its home project, the URL at which it can be accessed, which archive or home project the artifact belongs to, the artifact's title, which nodes it's federated under, what kind of digital artifact it is, the disciplines and genres to which the artifact belongs, and the date of publication. There are also a number of optional fields, since, as Brian said, every project has its own specific needs. And these can include things like edition information, the language in which the artifact is originally written, and even the full text of an artifact. And a full description of the RDF from which the artifacts are built is linked in the slide. Each artifact is also connected to one or more agents. The agent field links each artifact with one or more entities, who are the people or organizations responsible for producing the artifact, and the roles that those entities inhabit, such as author, composer, or publisher. In its default state, as it's ingested through the RDF provided to ARC, each entity only has a name and an entity type, as these are the kinds of information that were originally collected in the RDF. Our current task for bringing ARC's data in line with linked open data principles is attributing a uniquely identifying URI to each entity. Usually, an entity is a single individual responsible for some element of one or more artifacts. An entity can, of course, hold more than one role. For example, we could have somebody who is both an author and a publisher, or a composer and an arranger. And each entity can also be attached to multiple artifacts. So how do we go about attributing a URI to each entity? Within Corpora, there's a Python script that allows us to search VIAF, the Virtual International Authority file, using ARC's metadata on an entity's name, their associated dates, and their publications. In roughly 80% of all cases, this automatically generated list of potential VIAF entries will include the correct entity, as you can see in the example shown here, where that first entity is actually the one that we're looking for. For these entries, all that's needed is for a human to check VIAF's data briefly against ARC's data, verify that they're the same individual, and check the external URI verified button to complete the URI attribution process. However, in the other 20% of cases, further research is needed. In many of these cases, there simply isn't a VIAF for the individual in question. In others, there isn't enough information in either ARC or VIAF, or sometimes both, to make a positive identification. In these cases, we mark the entities as needing further attention, and we leave a brief comment explaining the nature of the problem. In a later phase of the project, we'll be revisiting these entities and locating either the correct VIAF or minting our own URI for the entity. So in order to verify an entity, we first look at the artifacts that are associated with them. Ideally, these artifacts will also be listed in the entity's VIAF, though this isn't always the case. However, from the associated artifacts screen, we can see useful information for verifying the entry, particularly the date of publication, and we can also access the digital artifact as it exists at its home project, which is usually helpful when working with lesser known entities. One of the most challenging parts of verifying a VIAF, an entity's VIAF, is the information tracked by ARC is very different from the information tracked by VIAF. Many of the projects cataloged by ARC are often focused on the artifact in its smallest discrete unit, such as an individual poem or an article or a letter, while VIAF tends to focus on major works like monographs or collections of poetry. In these cases, it's often necessary to make a best guess at an attribution based on publication dates and topics. For example, if the entity is a scholar whose connected artifacts are all reviews of books on Melville, and their VIAF entry includes a monograph on Melville, we generally feel safe in assuming that these entities refer to the same person. In many cases, VIAF will also link to other databases like WorldCat or the Library of Congress, both of which may list additional works that can help us be more confident in our attributions. In its original format, ARC's RDF only allowed for a single name to be associated with an entity. The Corpora now allows us to merge entities and add alternate names, which I will discuss a little bit later. VIAF, however, is helpful in that it includes all known name variations, which can be very useful in identifying entities who have published under more than one name, or whose names have been transliterated in a variety of ways. And then finally, VIAF also includes a variety of demographic information, most of which is not actually present in ARC. So this vetting process exposes a number of problems and inconsistencies in ARC's data, most of which are just introduced simply by the scope of the projects that ARC collects. With so many different projects, each of which has its own different interests and ways of thinking about and prioritizing data, we see a variety of different approaches to how each entity is presented. For example, if we search for the name Sarah, the first few entries give us a good sense of one kind of problem that we may encounter. The ways that different projects encode data, as seemingly unproblematic as names, can actually vary quite widely. So if, for example, here we have the mononymic Sarah. We have a couple of entities that have both an alias and a last name, presumably. This is like their married name and their maiden name, as well as birth dates and death dates. We have some that are just simply first name, last name, but we also have Sarah Moss and Moss, Sarah. And then all the way down at the bottom here, we have an all capitalized Sarah Joven, which isn't a problem for ARC, but might be a problem depending on what language you're using to interpret your data. So some of these entries are, of course, more helpful than others when we're trying to determine who these people are. For example, this second and third entry, they give us that married name and presumably a maiden name, as well as birth and death dates. And strictly speaking, these dates aren't part of the name and probably shouldn't be in this field. However, they do make identifying the individual much easier, particularly when the name is relatively common. This kind of inconsistency in the data is also present within VIAF, although to a lesser extent, with some entities including names as well as dates. With so many projects in ARC, it is inevitable that there will be some overlap in data, particularly when we're talking about canonical figures. Here, for example, you can see a sampling of our results for searching for Charlotte Bronte, and within this 223 entities, there are several others that are definitely that Charlotte Bronte further down. However, in this sample, we have 3, maybe 4 distinct entities. It's hard to tell who this mononymic Bronte at the top is. But because they appear in multiple projects, they appear as multiple data points within ARC. In our old catalog, there was little we could do about these overlapping entities, and there was little reason to alter them since the projects didn't really talk to each other in that way. Now, however, we can merge these entities, allowing us to create connections between the projects in which they appear. Merged entities will choose one authoritative entity as a starting point, a point of connection, and include all of the merged entities as potential alternate names, much in the same way that VIAF does. And then finally, there are a number of ambiguous entities, or entities for whom it is difficult, if not impossible, to assign a VIAF. These entities also have the potential to tell us a lot about how a project thinks about its own data. For example, anonymous authors often go unidentified, but not always. Sometimes scholars track down the correct author identity, years after publication. So in cases where an author has been identified, does the project list the author as they appear on the title page, or do they list the author as they've been identified? Alternatively, they could do both. In the case of an identified author, it is, of course, possible to associate a VIAF. But what do we do with an author who's listed as anonymous within an ARC project, but who's associated with an artifact that appears under an identified author in VIAF? These are questions for us to consider moving forward. And there are also several other naming conventions that commonly appear in ARC, either as a product of the original publication or as part of the data entry process. We frequently see authors whose names are given only as initials, or who operate under a nom de plume or other aliases, or who may have changed their names between publications. Even when we have a full name, some entities can be very difficult to identify within VIAF. Usually this occurs with very minor figures. Just a couple of examples I've seen in the last week: a modernist poet who only published once in a very limited run journal, or a 17th century woman whose name appears in a single court case. Neither of these people had VIAFs. They haven't been deemed culturally relevant enough yet, I guess. Sometimes, however, we have the opposite problem, and we'll have multiple VIAFs for what is clearly the same person with overlapping publications. And then finally, we also have some entities who are not a single individual at all, but who are publishing companies or corporations or multiple authors functioning under a single name, or other instances in which it is difficult to attribute a single VIAF. For all of these cases, we'll be needing to work with the Links project to determine how best to handle these exceptions. Okay, I've spent quite a bit of time talking about ARC's data as it will be relevant to Links and discussing the various rewards and pitfalls of working with such a large data set. However, I would like to end by drawing our attention back to Corpora as a tool for facilitating other DH projects. Right now, Corpora is still expanding. We're adding new functionality all the time, but its key features, or at least for my part in the project, are its flexibility and its accessibility. So data can be imported to Corpora from pre-existing projects, as Brian showed just a little bit ago. And Corpora's Python integration means that the data can be easily manipulated, examined, and analyzed. And for newer projects, artifacts can also be uploaded as PDFs and OCR'd within Corpora. And perhaps more importantly, for those who are new to DH or who have limited technical assistance through their institutions, Corpora's visual interface is a lot more accessible than many other database programs or data management systems that I've worked with in the past. We're also in the process of developing search tools that will allow Corpora's users to integrate their data into a WordPress site, making it much easier to get up and running out of the box. And this will also replace the outdated systems that currently support much of ARC. Thank you. We have enjoyed sharing Corpora and ARC with you today, and we look forward to continuing to expand these projects through our work with Links. We'll now be moving into a live demo of a few of the projects currently supported by Corpora, and after that, we'll have a little bit of time for questions.
Texas A&M, or rather the Center of Digital Humanities Research, is honored to host a legacy project called the Cervantes Project. And kind of one of the biggest assets of that project, aside from a kind of variorum edition of the Quixote, is all of the illustrations that comprise the various editions of the Quixote. So we have something like 60,000 different individual illustrations that we kind of track and allow editors to annotate. The reason I draw attention to this particular project is to note that Corpora is sort of fluent in IIIF. So if we go into the content type manager for the illustration content type, we can see that one of the data types that we can actually set up for a field is a IIIF image URL. So when that data is present, then, for instance, in this sort of search field, you get kind of a thumbnail of the image in question as a representation of the data in that field. If you were to open this record, you not only get the kind of HTML representation of the metadata, but you get a nice sort of viewer that allows you to kind of zoom in and focus or even, you can see it in a tiled view if you zoom out far enough. And this is handy for our editors who need to kind of go in and kind of, provide, like if they figure out that, this was an engraving and they figure out who the engraver is, or, provide other metadata about the object in question. I guess this particular image was scanned in, I think in like 1995 or 96, so it does not have a very high resolution. But there are other images in this project that are kind of scanned in at higher resolutions, which makes that a little bit kind of more useful. Let's see. Another project that we're hosting in Corpora right now is the Feminist Controversy project. And the goal of this project is to annotate, I believe, a bunch of 18th century novels that were written by women, or at least about women, with the goal of seeing whether we can develop a taxonomy of tags and tag all of the kind of like every kind of phrase in the novel under some sort of category here, and associate that with a character. So for instance, in the novel Azemia, Volume 6, we can take a look at this character, the brother of Charles. And what you see here are kind of other characters in the novel. And with the brother of Charles here, you can see that there are several taggings associating him with a particular occupation, being a caretaker, etc. Some of these data sets can get a little bit kind of noisy, or so let me take all the different characters of this novel and sprawl out their nodes. So you're going to see a whole bunch of nodes now appearing on the screen. These are taggings that basically associate a character with a tag. I could sprawl out every tagging and it would eventually show you sort of a relationship between characters and tags, with the number of taggings sort of indicating how strongly associated a character is with a particular tag. But again, as I said, this is a rather noisy kind of way of looking at that data. This interface allows people to look at aggregate views. So if we were interested in seeing the relationship between characters and tags via taggings, but we didn't want to see every single tagging represented as a node, we could collapse those. And what that allows us to do is sort of draw a thick line, for instance, connecting Miss Eleanor Grimshaw here to being deprived or gaining, with this thickness here indicating that there are quite a few taggings associating those two nodes. And once you've done that, you can kind of sprawl out looking for more tags associated with every character. And once this finishes sort of rendering on my browser, you can sort of begin to see, which characters are more strongly associated with which tags. And there are different ways to sort of wrangle this visualization. You can truncate the labels so that they're not as verbose. You can hide them all together. If there are particular sort of data types that are causing kind of some traffic jam, like the fact that every single one of the characters is associated with this document, you can click on a node, choose to hide it, and really kind of sort of refine what it is that you're seeing, or even hide every instance of a particular content type. So, okay, great. We got a question here from Sandra. what are the advantages of Corpora versus Gephi visualizations, assuming that one has all the data in CSV files? Well, Gephi is a wonderful sort of network visualization tool that is going to allow you to really have a fine kind of grained control over, you know, how you're sizing the nodes, what color the nodes are, you know, what algorithm you're using to lay out the graph, etc. Corpora is definitely going to not be as flexible. It's going to have some defaults that, you know, you may want to eventually sort of bring into Gephi in order to, you know, fine tune. However, when you have a very large data set and you're trying to kind of determine, you know, maybe what visualizations would be useful to bring into Gephi or whatever, it's sort of a staging ground for being able to explore your data without having to just kind of be restricted to a more tabular kind of data format. All right, let's see here. Thank you, Lauren, for addressing that question in the chat.
There's one question from Sana as well. She asks, is Corpora a tool used by a researcher? And then about the relationship of Corpora to the Links project.
Yeah, so right now, as far as I know, Coder is the only kind of organization that is making use of Corpora. We certainly allow faculty members, grad students, you know, staff, whoever has like a DH project in mind to use our own hosted instance of Corpora to build their kind of data set out. As I talked about before, though, one of the kind of cool parts about this Links project is that because we're using Corpora to, you know, basically take all of this metadata inside of Arc and sort of convert it into, you know, those turtle statements I was showing you earlier that can be ingested into the Links triple store. We're also going to just spend the time to write up good documentation for Corpora, move it from our private sort of GitLab repository, put it up on GitHub, and sort of launch it as an actual open source project that the DH community at large can make use of, can kind of help us develop, etc. So hopefully here in a year or two, maybe sooner, that is going to be available. And with the documentation we hope to create, any researcher with, you know, a laptop could download kind of Corpora, launch it, and use it to build their own kind of data set. So we're excited about that happening in the near future. Yeah, and in terms of its relationship to Links, we are using this as the tool to perform all of the conversion, right, of our data to, you know, those Links turtle statements. So any artifact in Corpora can now be sort of rendered as the turtle statements necessary that really adhere to kind of the Links ontology as sort of defined and fleshed out by Aaron Canning. So, and again, that template is easily sort of created and modified using this template editor. And you can, of course, create new templates if you wanted to represent this as like an HTML snippet or anything like that. It just uses a very simple kind of templating syntax. Those of you who are familiar maybe with creating websites using Markdown or maybe with like liquid templates, that's a very similar kind of templating convention to the one built into Django. So that's specifically one of the ways we're using it with the Links project. Okay, Peter's got a question here. Could I share the process or design for keeping the corporate data in sync across 3 databases? Yeah, so The way that works is in the Python code for Corpora, there is a class that is simply called content, and it's kind of like an abstract class. Based on the schema that you create using this kind of content type manager, it creates something called a Mongo engine sort of class by default, which allows you to sort of specify the different fields and then save all the data to a MongoDB instance. We then have special hooks into the kind of save, update, delete sort of functionality of a Mongo engine class, such that anytime we save the data to MongoDB, it also fires off the task to update the data in the Elasticsearch index and also create the nodes and edges inside the Neo4j database. So in that sense, we really kind of use MongoDB, I suppose, as the ground truth or the most base kind of storage for the content. And then it sort of gets crystallized out into Elasticsearch and Neo4j. So for that reason, if you were to write a programmatic task to modify a whole bunch of data in MongoDB, maybe not even using the Corpora API, we have ways of allowing you to re-index that data across the other databases to kind of regenerate all the labels. So, labeling, for instance, is another template. So the label for any given piece of content can be kind of customized in that way as well. Did you have a follow-up question? Sorry if I interrupted.
No, I just want to say thank you for answering that. Explains it really well. I was wondering if Mongo was the main or, the ground truth master database, as you called it.
Yeah, one of the things we're sort of hoping to implement is a feature that would allow you, when you're editing a piece of content, or a content type rather, to specify more granular options, including a way to automatically also just output JSON flat files for every single piece of content. So that, maybe in the background, if you've changed a whole bunch of data at once, there's, some periodic tasks that will go through and crystallize that data, saving it as flat files, making sure it's sort of reconciled with the other two databases. And those JSON representations are very simple. So again, if we were to look at the JSON representation for this particular artifact, that file would just look like this, which could be easily kind of read in and used in another database or used for other purposes. So we try to make it as kind of interoperable as possible in that way.